We begin with the car on the road from last time and implement a way for it to sense the borders like this. It will be really important later when we teach the car to drive itself. Otherwise, it won't know what to avoid. The sensors work in the same way real sensors do, and we'll use a technique called ray casting to implement them. It's very common in games so that enemies can see you moving around. We'll be able to change the number, length, and spread of these rays any way we want. It's best if you code along with me, so open the project, and if you want to use this exact version I'm using, then get it from GitHub, and let's bring this car to its senses. Get it? Senses? Because we're gonna... No, 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 no! Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now. To add sensors to the car, I'm gonna go to index.html and include here sensor.js, save this file, and create a file called sensor.js like this. And inside here, I'm going to define my sensor. And the constructor will take the car as the argument. And the reason is that I want the sensor to know where the car is. It's attached to the car, and we're going to be using the car properties to update it. So let's store here the car, and other attributes will be the ray count. So our sensor will cast rays in different directions, and let's just have 3 of these rays for now, and then the ray length. So usually sensors like this have a range after which they don't work anymore. So if they don't sense anything in this 100 pixels range, then they can see beyond that. And array spread. So here I'm setting pi divided by 4. This is the same as 45 degrees, and that means the angle that we are going to spread these rays that are being casted by the sensor. So I'm going to keep here also an array called rays, and this is going to keep each individual ray one by one after we create them. I'm next going to create an update method like this, and we begin by setting these rays to an empty array. So this arrays is what we are going to start to populate next. And to do that, I'm going to loop from 0 to this ray count like this, and I'm going to figure out the angle of each individual ray. And to do that, I'm going to use the lerp function, our utility function from earlier here, that gives us a value between a and b depending on t, right? So if I go now back to sensors, the angle here is going to be between ray spread divided by 2, remember the unit circle, the rotated unit circle, and minus ray spread divided by 2. And the t value, let's have it I divided by this ray count minus 1 this time, because I is not going to become equal to ray count. So the maximum value for I is this ray count minus 1, actually. Need to remember this. It's quite important. And with this, we can calculate the start point for our ray, and that's just going to be the car, x and y, like this, and an end point of the ray. For this endpoint, I'm going to take the car x as the starting point, and then using the unit circle, I'm going to take this angle that we made previously and multiply it by the length. So unit circle, just 1 pixel radius, we won't see anything. We need to scale it up by the ray length here, and we do the very same thing with the y, but with the cosine there instead. Now, with this start and end point available, I'm going to push these inside of the array to form a segment. So notice here, I'm using this way of defining the segment using an array here, in the same way that we used for the borders here in Road.js. The road borders are also going to be made of segments defined in this way. It's good to be consistent like this. Now, we also need to be able to draw our sensor, and I'm going to say draw, and we go through all of the arrays like this. Begin a path, and I'm going to put a line width of 2, and I'm going to draw these rays using yellow. I will move to the array's start location, x and y. So the first thing in the array of I array is its start location. And then I will line to the array's end location, so 1 with x and y there like that. And now I can stroke and close these like so. I seem to be missing here a curly brace. Let's save this file and now instantiate this sensor. I will go to car, and inside the car constructor here above the controls, I think it's good. I'm going to say this sensor is equal to new sensor of this, so I'm passing the car to this. And then in the update method here, I'm also going to be telling the sensor to update like this. And in the draw, in addition to drawing the car, I'm also going to be telling the sensor to draw itself. So the car has now the responsibility to draw its own sensor. Let's save this, refresh. Okay, so we see now 3 lines popping out from the center of the car like this. And they're at a 45-degree angle, which is good. And when we move the car, maybe this is not what you want to happen. Maybe it is what you want to happen. I don't know. You can experiment with these things. But I would like the sensor to rotate with the car so that when the car moves, the sensor also moves. But nowadays, with gyroscopic technology, you could probably have this kind of sensor as well if you actually want. So to fix this, it's really easy. I just add here to the ray angle plus this car angle like this, and it works as expected. Let's play a little bit with these values up here more. For example, let's have 30 segments and make them a bit longer like this. Wow, so many rays coming from there. It's like the sun. Let's actually go all the way. So pi times 2. This is now spreading these rays in all directions, so all 360 degrees, or pi times 2 there. Let's put it to half pi, so a 90-degree angle. I think I like that. And let's try with ray count of 1. We'll have a surprise here. It doesn't work. 2 works just fine, but 1 doesn't. And the reason for that is this thing here. This ray count minus 1, if ray count is 1, then this becomes 0, and we can't divide by 0. So what I'm going to do is I'm just going to replace this line. If this ray count is 1, I'm going to just return half. I want my ray to be straight up in the middle between the ray span. Otherwise, I just do the exact same thing as previously. So now it works. No problems. And we got it to work. We needed to do a little bit of more thinking right here because of this division by 0. Let's try with more rays to see if that still works. Maybe 5. Okay. Nice. Now, before we get them to work, to actually detect that there are some road borders here, I want to refactor this a little bit. So all the code here in this update method, I'm going to cut it, and I'm going to say here this dot private method cast rays, like this, and cast rays is going to get this code right here. This doesn't change anything, everything still works, but now our update method here is simpler and more code can go into it and we can read it more clearly. Now, to be able to detect the road borders, we need to know where they are, and at the moment the sensor has no idea. We need to go to main.js and first pass to the car update method the road borders, like this. Now I'm going to go to car.js and have the road borders here, like this, and I'm going to take them and pass them to the sensor update as well. So now in the sensor.js, the update method receives them as well, and now we can use them to detect with the sensor if the road borders are close or not. I'm gonna add here an array for the readings. So these readings are going to be some values for each ray telling if there is a border there or not and how far is it. Now in this update method, I'm going to say readings is equal to an empty array. I initialize it here, and then I will iterate through all the rays like this and add to this readings array a reading. So we will get readings using a new method that we need to define that takes an array like this and the borders as parameters. And now we're going to go down here and write our getReading method with array and the given borders. So now what I'm going to do is check to see where this array touches the road borders. And now we have just 2 borders, one on each side. So one ray can only touch both of them if the car goes off screen like this. But it's good to consider multiple intersections anyway, especially because later we'll have traffic. And we'll handle that using this same strategy as well. What we'll do is find all these touches and then keep the closest one to the sensor. And that will be our reading, in the same way that a real sensor would work. So let's see where this ray touches any borders. These touches is gonna be an empty array. And I'm gonna go through all the borders one by one. We just have 2 at the moment, but it's good to write it like this. And we say that the touch is equal to getIntersection. This is gonna be a function that we will need to write. It's gonna be a very useful utility function. You'll see. And the intersection will be between the ray of 0 and the ray of 1. So this is gonna be one segment so far. And another segment, the ith road border 0 and the ith road border 1, like this. Now, if there is a touch, we will add to our touches. So this getIntersection function may return null if the segments don't intersect. So in that case, nothing gets added to this touches array. Now, if we have absolutely no touches with the given array, then that means that there is no reading here. We don't encounter anything with this array. So I'm gonna say here return null like this. Otherwise, and now I'm gonna teach you a little bit more modern JavaScript. You see, this get intersection doesn't just return the intersection point, but also an offset, how far the point is from this array of 0, which is pretty much the center of the car. So we do get with this get intersection 3 things, an x, a y, and this offset value that will be quite useful. So I just want all the offsets from all the touches here in one array, and we can use modern JavaScript methods to get that. Like this. The array map method basically goes through all the elements from this array, and for each element, it takes its offset. Now this part here returns a new array. In this case, it's called offsets. And that's it. We don't have to write a lot of code to get this result here. And I think that's great. Now, we want to know from all of these offsets, the minimum one. Like if array touches many different things, like many borders or cars will be later when we add the traffic. So we want to know the nearest one. After the array touches that, all the other ones don't exist basically. So we are going to get the minimum offset using the math minimum method. This minimum method here doesn't accept an array as an argument, but it does work with many different values. So this dot 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 operator is spreading the array into many different individual values. And finally, I'm going to return the touch that has this minimum offset using this find method here. So going through all the touches, element by element, if the offset of that touch is equal to this minimum offset, it will return that touch in this way. This code is pretty complex, take a while to look over it. But because we're using modern JavaScript methods here, the code is really short. So try to get used to this syntax because you will see it everywhere, especially if you work with React. Now I'm going to draw these readings somehow here. In the draw method, let end is equal to the array's endpoint pretty much. But if there is a reading, I'm going to set end to the value of that reading. Remember, the readings, what comes from this get intersection function will be 3 things, the x, the y, and the offset. So if we say this here, we essentially pass the x and y to this, and end becomes a point with an x and y attributes. I'm gonna now make this yellow segment until end right here, like so. And I still want to know where this line would have continued. I think it's nice to visualize that. So I'm going to copy all of this and I'm gonna just make it, let's say, black. And here I will draw from the tip of where the end of the array could be to this endpoint, if it's a reading or not. If not, then this is just going to be a line that is so small you can't see it. Now, if I save all of this and refresh, it works for me, but it doesn't work for you. And that's because I have here in the utility file a secret function that I added without telling you. Sorry. Let me just indent this a little bit like so that you can actually see it. If you want to implement this yourself by watching on the screen right now, I will make a separate video for this because I think the topic is very interesting and I have a nice way to teach it as well. But it works. Look, when I'm moving my car like this, the rays are going to the borders, and immediately when they are reaching the borders there, they are turning black like so. And only the yellow part is really interesting, and it's what we will use later when we define the neural network. We just implemented ray casting, a very popular algorithm in game development. There are, of course, many existing implementations as well. Three.js actually has one of them, and you can use Three.js to make 3D projects as well. It would be really cool if one of you guys makes a 3D version of this. Now, there are other types of sensors as well. Feel free to implement your own if you have better ideas. Some real-world cars actually use cameras here as the sensors, and then use image processing techniques to figure out things like cars, people, road signs. But those things are beyond the scope of this course. I just thought you'd like to know. Were you able to follow along? Then great. Please like this video if you learned something today, and share it with others so they can learn as well. And if you got stuck somewhere, comment below and I'll try to help. You can get today's code from GitHub, and the full code is actually already on my website. Check it out if you can't wait till the end of the course. See you guys.